So we're going to talk about transformations and the simplest transformation is the location scale transformation. You might have seen this before. When we did Z-scores in undergraduate statistics, you can merge a regular observation to a Z-score. So if you take an observation X, you subtract the mean and divide by the standard deviation, you end up getting a new random variable. And that random variable is the standardized Z-score. So this is an observation. And that is the Z-score. And in terms of a distribution, if X is normally distributed with mean mu, variance sigma squared, you subtract the mean, divide by the standard deviation. This would end up being standard normal. Probably called mean equals X bar and variance equals S squared. Bad notation, but just to get the point across. So a transformation would simply convert one distribution to another. Any thoughts as to why we call it a location scale transformation?
Kind of takes it from where the data is kind of zero. So instead of just relatives, well, I guess it's just looking at it from a relative perspective.
That is correct, actually. So if you look at the numerator, you're moving an observation to its center. So you are changing the location. Anytime you divide by a number or multiply by a number, it simply means you're scaling the observation. So this is what we call a location scale transformation. So, this is a location scale transformation of the random variable X. B would be the location parameter. And A would be the scale parameter. So you're scaling the random variable X by a value, you're shifting it around, so you're changing the location by B, so location and scale. So how do we find the density of Y? We typically start with the PDF of Y. Now, Y is A times X plus B. Yes. And subtract B on both sides. And now I divide by A on both sides. And that's exactly what I was after. How do I write this in terms of the CDF of X?
But like f of y minus b over a.
So we have the CDF for Y. How do we find the PDF? Derivative. If we take the derivative on both sides, should it be with respect to Y or X? I'm going from here to there.
So
It should be with respect to Y. F of X, it's a CDF of X, but we converted it to a function of Y. So naturally I can take its derivative. So the derivative here would simply be Fx of Y minus B over A. But are we done there? It's not X, rather it is a function of X. So what do we do when we take the derivative? There is a rule. Chain. What is the derivative of Y minus B over A? Good. So we know one of the key things with random variables is the support. Support is important. So what is the support of X? The support of X is between 0 and 1. If I multiply by 2 on both sides, I'll have 0 less than 2x less than 2. Add 1 on both sides. 1 less than 2x plus 1 less than 3. Yes? So 1 is less than y, less than 3. Yes? So the support of y happens to be 3. Great. Let's go to the transformation. So I actually did the work. We know Fy of y is simply the CDF of X evaluated at Y minus B over A. If I want the CDF, but I want the PDF, so I could just go for that. So Fy of y would equal to the density of X evaluated at Y minus B over A multiplied by 1 over a. The 1 over a comes from the derivative of the inside. So in our case, what is a? A is 2, B is 1. Yes. So if I plug that in, I have y minus 1 over 2 times 1 over 2. Good. So what is the answer? Well, in order to find the PDF of y, I've got to know the PDF of x. What is the PDF of x? You should know this by now. Most important
Was it
distribution.
X minus B, X minus A for B minus A?
That is the CDF of the uniform. I want to know just one. So fx of x is just 1 for all values of x in 0 to 1, 0 otherwise. That said, now, what is the density of y? Algebra people.
This was 1, 2,
1 half,
2.
2. Why is it 2?
This.
One piece at a time. If you plug in y minus 1 divided by 2, what would you get? If you plug in y minus 1 divided by 2 for x, what would you get?
Something between 0 and 1.
Oh,
Some sort of fraction. Oh, wait, no, that's.
not necessarily.
What does it take plugged into?
fx of x.
Either 0 or 1.
If I change the value of x, would the value of the density change?
Would be 1.
Will it? Algebra. If I change the value of this function, change the x value, would it change the value? What is fx of 0.2? What is fx of 0.3? fx of 0.7? fx of 0.15? fx of y minus 1 over 2? Still 1. Right? Because in places where I did not define, it's just 0. Correct? So the only places it is going to work would be where I plug in y minus 1 over 2. If you plug in 1, support of y, 1 minus 1 is 0, 0 over 2. That's where it's going to start. And it's going to end at 3. 3 minus 1 over 2, 2 over 2, you get 1. no matter what value of x you plug in the support of random variable x, you will always get 1. So that number is always 1. 1 times half is half. And the support of y is 1 to 3. Not 1 to 3, it's 1, 2, 3. I don't know if that made a difference. It still sounded the same. Yes?
So
Exactly.
with the brackets.
It doesn't. Good. So we've answered that. How do we find the expectation? Well, what comes to your mind in terms of finding the expectation? How do we find the expectation? Matthias says integral what?
1, 3, PDF.
Of the PDF. It is x times the PDF integrated over 1 to 3. But should I do all that in this problem? Is it necessary? No. Because we know expectation of y can be written as expectation of 2x plus 1. Yes? Distribute expectation of 2x plus expectation of 1. What is the expectation of 1? 1. I can pull 2 out, so 2 times expectation of x. 2, expectation of x, we know what that is, right? A plus b divided by 2. For a uniform, it would be half. So 1/2 times 2 plus 1, which gives me 2. Correct? So the things that I have realized about y is that y is between 1 and 3. And yes,
How did you know the expectation of x is 1/2?
that is the expectation of uniform, a plus b over 2. So 0 plus 1 over 2. So we know that support for y changed. Call it y. Fy of y. Because we're talking about the random variable y. So we move the support from 0, 1 to 1, 3. The value of the density is always half. In addition, the mean is 2. So by the looks of that, is it a proper density? Well, 1/2, we just want to find the area of that rectangle. So 1/2 times 2, 1, density. And it is defined between 1 and 3. And mean is 2. Based on that information, is y a uniform variable? Yes. The y is uniform, and what are its parameters? One and 3. Good. So no matter what random variable you have, typically a location scale transformation is the easiest transformation. That's number one. Number two, when you try to find the expectation variance, if you have a transformation, you needn't go and integrate everything. As long as the transformation is location scale, you can simply use the properties of expectation. Does that make sense? It'll work for location scale, but not for the other ones. Good.